35, because they were doing it.
Okay,
She
on
was
number
doing it on the
one,
ones and she was doing it on the zeros. This is the centimeter, and this is the steps.
you're given the equations of two lines, okay? Those lines should be parallel, all right? So you will plot those points, plot those lines, right? And then I give you the equations, I think, of two vertical lines. Maybe it's two horizontal lines. Could be either. Now, do those lines form a parallelogram? Do you remember what a parallelogram is? It's where two sides of a triangle are parallel, and the other two sides are parallel to each other. Okay? So we got two sets of parallel sides. That's a parallelogram. Okay?
A equals B times H.
Now, the area of a parallelogram is equal to the length of its base times its altitude. Okay? So we have to use one side as a base and the other side, other two sides we're going to use to get an altitude. Okay? So it's probably going to be more convenient to have our base either vertical or horizontal. Okay? So we can call this the base, or we can call this the base. Now, if you call this the base, you're going to get into equations of perpendicular lines and you're not going to be happy. We want you to be happy. And then we'll make you do it with perpendicular lines so you can be unhappy too, but not next time. Okay? Because if you can do that, that's a pretty challenging problem. If you can do that, you can probably do just about anything. Okay? And I think most of you can. Okay, so I'm going to call this the base. Okay? And then the altitude goes from the base to an opposite vertex. Okay? Now, in this case, and in the case of the problems you get, it's very likely that the base will need to be extended.
Yes.
So here's our extended base, okay? And an altitude goes perpendicular to the base to a vertex that's not on the base. So that's like this. So here's an altitude. Let's go this one because it's going to be easier to label. Okay, this is a right angle. It goes from the base to a vertex. The vertex is where two of these lines meet. It's a corner of the parallelogram, right? So here's an altitude. There's also an altitude here. Whatever you choose for the base, the altitude goes perpendicular to the base. Okay? So if you know that this is, let's say, x equals -2, and this is x equals 5, and let's say one way or another you know that the base has a length of 3. Base has a length of, probably closer to 2. Yeah, 3's all right. Suppose the base has a length of 3, right? Okay? Now, the area equals base times altitude, just like it does for a rectangle. If you have a rectangle, it's like length times width. Well, If your base is the length, then your width is the altitude, right? Because your width goes perpendicular to your length, and so forth, okay? And I'm not going to go into that. We might, at some point, talk about how you can decompose this into a rectangle. It's
Okay,
not
'cause I
hard,
did that. That's what I did.
okay?
Is that,
Yeah, because that's like.
Is that
Well,
okay?
I mean, you can trim a triangle off here, turn it upside down, slap it on here, and then you got a rectangle.
if we did that on the homework, is that okay? Because I did that for,
Well, if you
Yesterday,
got the
so-
right numbers,
okay.
okay? Anyhow, area is base times altitude. Well, what's the altitude?
7.
Altitude 7. It goes from -2 to 5, and it's perpendicular to the base, and the base is vertical, so the altitude's got to be horizontal, right? Horizontally, from x equals -2 to x equals 5 is 7, right? Okay? So if you determine what the base is, which you can pretty easily, but yeah, there's a little bit to that. You got this. Now, getting there from the equations of the lines is still a little bit tricky, but that's what we're talking about. Okay? So see what we can do with that.